Hello, everybody. Good morning. Good evening. Thank you for joining us for today's webinar, Accelerating Wideband SDR, Radar, and EW with Agilex 9 Direct RF-Series, the Altera and iWave Advantage. My name is Sophia Goldsberry, and I'm with Altera's corporate marketing team, and I'll be your host for today's session. Before we begin, I have a few quick housekeeping notes. All attendees' mics and cameras have been turned off for the duration of the webinar. This webinar is being recorded, and all registrants will receive an on-demand recording and a copy of the presentation approximately 1 week after the event. If you have any questions during the presentation, please submit them using the Q&A chat box at any time. We'll answer as many questions as we can during the session at the end. If we don't have time to answer your question live, someone from one of our teams will follow up afterward. With that, let's get started. It's my pleasure to introduce today's speakers. First, we have Shriram, Hardware Product Manager from Altera, followed by Ahmed, Associate Director from iWave. Shriram, I will hand it over to you.
Thank you, Sophia. Good morning, good evening, everyone. This is Shriram Govindarajan, Altera Hardware Product Manager. I am from the product marketing team at Altera, responsible for the Agilex 9 product line. All right, so I wanted to get started with highlighting some of the major challenges for modern RF systems today. So if you can see the images on the left of the screen, you can see that these systems have a lot of complexity, a lot of components inside them, but limited real estate, especially for electronic components. Also, these systems are in the field, have a long lifetime, and go through multiple upgrades, changes, but at the same time have to come under, need to have limited power constraint envelopes. So that's why swap, which is size, weight, and power, is becoming an increasingly important requirement for such systems. But this reduction in swap should not come at the expense of the capabilities of the device. So it could be RF spectrum dominance or being the ability to quickly respond in real time. So RF performance with low latency is another critical requirement for these RF systems. Also, fast time to market is critical because you want to be able to adapt to evolving challenges in the field without major system overhauls. And that is where integration and modularity becomes a core need for rapid deployment and system updatability. Ideally, you would want to have plug-and-play solutions with industry standard form factors like 3U-VPX so that you can deploy your system in the field quickly. So with that, I wanted to highlight, show how RF architecture has evolved over the years to address these challenges. I'm taking an example of a 32 gigahertz signal at the input of the antenna here. So if you look at the picture at the bottom, which is the super heterodyne architecture, you can see that the ADC on the right typically has a sample rate of a few hundred megasamples per second. And so you need a lot of front-end components in order to down convert the signal from the antenna before it reaches the ADC. As we move up the value chain, if you look at the Direct IF architecture, we can see that the ADC now resides, say, in a device like the AMD RF-SoC Gen 3. And the number of external components has reduced, but you still need external components to down convert the 32 gigahertz signal at the antenna. And finally, if you look at the Direct RF architecture at the top, with the Agilex 9 device, the ADC inside it has a sample rate of up to 64 gigasamples per second. So the signal from the antenna, the 32 gigahertz signal, can be directly digitized and processed inside of the Agilex 9 device. So what you get with Agilex 9 is increased performance, reliability, along with lower power and a smaller system footprint. So as I said, Agilex 9 is the next step in the evolution of the Direct RF architecture, where you bring in the digital processing capability closer to the Direct RF data converters. And this is possible because of Altera's heterogeneous chiplet-based architecture. Now, if you look at the picture on your right, you can see that there is the data converter chiplet in red, which is sharing the same packet substrate in dark blue with the FPGA die, which is in the light blue color. And they are connected by a bridge, which I have denoted as EMIB and AIB. So EMIB is embedded multi-die interconnect bridge. It's a silicon channel with routing similar to that in a die. And AIB is Advanced Interface Bus, which is the open standard protocol that runs on top of the EMIB bridge. So what are some of the advantages of such an architecture? So you get a single package solution that reduces your system footprint. So instead of having discrete chips for the data converter and the FPGA, you now have a single package for the entire solution. It also enables higher bandwidth, lower latency and power compared to discrete solutions that I just mentioned, which need to use SerDes transceivers and JSG204 protocol for the data converters to interface with the FPGA. And finally, not only you can swap chiplets, but also the main FPGA processing die so that you can optimize your solution based on the target system needs. And this also helps address time to market. With this particular architecture, Altera has been able to get multiple MCP or multi-chip package products in the market in the last 5 years. So I wanted to also show how Agilex 9 FPGAs are built using this heterogeneous chiplet-based architecture. So if you see the figure on the left, you have the Agilex core FPGA fabric with the SDM, which is a secure device manager, and the HPS, the hard processor subsystem on the top. These components are in every Agilex 9 device. On the bottom, there are the memory interfaces. And on the right, you can see the ADC DAC chiplets or tiles that are connected to the fabric using EMIB. And on the left, you can see the SerDes or transceiver tiles that are connected to the core fabric using the EMIB. So what do you get with these devices? You get up to 64 gigasamples per second of sample rate with an unprecedented 32 gigahertz of receiver instantaneous bandwidth, which is unlike anything you can find in the market today. Not only that, you also get the Agilex core fabric performance per watt advantage, as well as fast transceivers to move data in and out of the device quickly. And all of this you get with significant swap savings. If you see the picture on the right, you can see an Agilex 9 board, the size of that board, which has a 50 by 50 millimeter package Agilex 9 device inside of it. And compare that to the typical system hardware, which has multiple discrete components and their associated power supplies, cooling equipment, and so on. And finally, with Agilex 9 being an FPGA device, you get real-time programmability, so you can adapt to evolving challenges in the field without any major system overhauls or downtime, with features like partial reconfiguration, where you can load persona-based specific classified processing while the rest of the system is active, and also frequency agility mode in the data converters, where it can quickly shift the receiver frequency while simultaneously enabling wideband and narrowband tracking. So I wanted to go over the Agilex 9 Direct RF-Series portfolio, the devices that are shipping as of today. It's a bit of an eye chart, so I'll walk you through it. The first device that you see on the left is the AGRW014 or the MCP1. It has one A tile, which is the wideband RF tile, and one F tile, which is the SerDes tile. So the A tile has up to 64 gigasamples per second of sample rate with 4 10-bit channels per tile. The device by itself has 1.4 million logic elements with 12 58 gig PAM4 transceivers. To the right, you can see the AGRW027 or the MCP2, which is the big brother of the MCP1, with double the number of A tiles, double the number of F tiles, and almost double the number of logic elements, 2.7 million logic elements. And finally, on the right, you can see the AGRM027, which is the MCP3, which has two D tiles. A D tile is the medium band tile with 4 gigasamples per second of sampling rate for the ADCs and 12 gigasamples per second of sampling rate for the DACs. It has 10 ADC channels and 8 DAC channels, all with a bit resolution of 14. In terms of the logic density and the transceiver channels, it is similar to the MCP2 device. So in terms of customer benefit, you can see that both the MCP1 and the MCP2 have wide bandwidth signal processing capabilities. The MCP1 comes with a small footprint, while the MCP2 offers higher channel count. And for the MCP3, it has the highest channel count amongst all these devices, as well as the highest spectral purity. So these devices are optimized for, but not strictly limited to, applications. For instance, MCP1 and 2 are optimized for EW, signal intelligence, radio astronomy, high-end RF test and measurement, and quantum computing, while the MCP3 is more optimized for radar, secure comms like 5G military comms, and quantum computing. All these devices are in production today. Okay, I also wanted to go a little more in detail on the wideband and medium band data converter tiles. So you can see the wideband, that is the A tile, has a RF range from 0.100 megahertz all the way to 36 gigahertz. So it has a ADC IBW of 32 gigahertz and a DAC IBW of 8 gigahertz with a 10-bit resolution. And both the ADC and DACs have 4 channels each with an integrated digital down converter and digital up converter. So if you see the figure on your left, you can see that each port ADC DAC has its own PLL, and it has its own coarse DDC, and followed by a fine DDC or a DUC, which has 4 fine tuners inside of it. Whereas the medium band device has an RF range from 100 megahertz to 7.125 gigahertz, with ADC IBW of 2 gigahertz and a DAC IBW of 2.4 gigahertz, a bit resolution of 14, and it has 8 ADC channels, as well as 2 feedback ADC channels and 8 DAC channels. Here you can see on the right, there is a common PLL that drives all of the ADCs and DACs, and they all of them come with an integrated digital down converter or a digital up converter with 2 processing parts inside of each DDC or DUC. Finally, I wanted to emphasize that the medium band device is based on a non-interleaved architecture, but there is flexibility for interleaving as well. And Altera is continuing to invest in the Agilex 9 technology by introducing its new Agilex 9 device, the AGRW039. This multi-chip package combines the same data converter tiles, wideband data converter tiles, along with much more fabric resources, 3.9 million logic elements. And you can see the gen over gen increase in terms of the compute capability per square millimeter, as well as logic and DSP density increase, which enable more beamforming and data queue processing at the edge. With this device, you also get DDR5 and LPDDR5 support with a hard network on chip controller. So this helps not only free your Agilex fabric resources for routing, but it also enables fast memory access. Right now, these devices are sampling to a limited set of customers with production rollout starting from next month. So I've spoken quite a bit about the integrated hardware benefits of Agilex 9, but I also wanted to emphasize the integrated tool chain that comes with Agilex 9, which integrates the Quartus Prime design software with the RF debug tools, IP, and support that come with it. So if you want to get started on evaluating the Agilex 9 device, you can do that by a development kit and the integrated RF toolchain, which comes with capabilities like the Direct RF Analyzer GUI, also called as the EDC DAC Cockpit GUI, which enables you to test the RF functionality. You also get tools like the evaluation platform, which can be used for detailed RF performance analysis, as well as tools like SPUR calculator and latency calculator. And finally, these devices also come with a bunch of reference designs that showcase the capabilities of the device, from time delay beamformer to channelizer to waveform classification using AI, multi-device synchronization, and wideband agility features. So in short, it's not just the integrated hardware, but also the integrated software solution that comes with Agilex 9 and that enables system-level debug. So instead of having separate tools from different vendors and having to make them work together, this is like a one-stop shop that helps enable system-level debug, remove your schedule risk, and help you complete your prototyping and development work faster. So what are our customers saying? Some of these customers who are using our Direct RF series devices are already seeing the benefits, and you can see the testimonials from some of these customers who have used our devices in their prototyping systems. But the overarching message that I wanted to highlight that we are hearing from our customers is that previously unattainable missions are now enabled entirely due to this high-performance, low-latency swap solution. And that customer praise is for good reason, because Agilex 9 devices are the best integrated FPGAs today across the entire RF spectrum. And I've showcased that using the 3 graphs here. If you see the graph on the left, it compares the Agilex 9 wideband devices versus the Versal RF devices, which are still not in production, expected to go into production sometime in next year. So if you see in terms of both the sample rate as well as the RF range, the Agilex 9 wideband devices offer 2x the performance. And in terms of IBW, the Versal RF devices go up to 18 gigahertz. But a caveat here is that their IBW is an aggregated IBW across all their channels to get to 18 gigahertz, as opposed to the Agilex 9 device that can give you an IBW of 32 gigahertz on a single channel. If you go to the graph on the middle, you can see the Agilex 9 medium band device versus the Zinc RF SoC Gen 3 device. So in terms of both the KLE count and DSP blocks, you can see that the Agilex 9 devices offer up to 3x more KLEs and up 4x more DSP blocks. So you typically need a companion FPGA to go along with the RF SoC devices, but that would not be the case with your medium band devices, which pack a lot more processing capability in a single device. Not only the swap advantage, also Agilex 9 medium band device has a non-interleaved architecture as opposed to the RF SoC devices, which have an interleaved architecture. And finally, comparing the Agilex 9 device to the discrete RF plus FPGA solutions, we have heard customers say that they're seeing swap improvements up to 10x, along with latency improvements and the IBW improvements because of Altera's advanced packaging technology. Now, another factor that is critical for Agilex 9 is the ecosystem of modular plug-and-play COT solutions, which help with time to market. And there are multiple factors that are driving the need for it. First is the rapid adaptability to evolving threats with what's happening in the world today. Also, customers, if they design a solution for one platform, they want to be able to reuse that across different platforms. Modernization of existing deployments upgrades are happening across the world, with governments spending more money on various modernization programs. And finally, lower total cost of ownership is critical because a customer doesn't want to worry with building their own design team and schedule risks. And that is where the power of COT solution comes in with our partners like iWave and their COTS solutions. They can help you accelerate the transition to proven fielded production systems. And before I hand it over to iWave, these are some of the reference materials that you can take a look at. There are QR codes here that you can take a look at. And with that, I will hand it over to Amit from iWave. Thank you.
Thank you, Shriram, for the detailed overview on Agilex 9 and the Direct RF solutions. Yeah. Good morning and good afternoon, everyone. Before we get started, I'm Ahmed Shamim from iWave Global. I've been iWave with more than 15 years, and currently I work as Associate Director. In my role, I closely work with defense and aerospace requirement. Yeah. So as Sriram explained, we have seen how at chip level direct RF technology significantly reduce the number of external components by integrating ADC, DAC along with the FPGA fabric and ARM core. So on on a single SoC, and helping reducing the size, weight, and also power, ultimately supporting that overall the SWaP-C objectives. So when it comes to the system design, the expectation is almost similar. If you look across almost every industries, whether it is a radar or electronic warfare or wireless infrastructure, quantum computing, even AI at the edge, the customers are looking significantly more performance than before, but in a very compact form factor. But as we all know, as the system size gets smaller, the engineering challenges become much bigger. So now if you see, along with the reducing in size, so every new FPGA generation delivers higher bandwidth, faster transceiver, higher sampling rate, and more processing capacity. So, but all this performance comes with increased power consumption and higher thermal and design complexity. And every engineering decision, like from component selection to the PCB layout, so which need to be carefully optimized to meet the current market and the swap objectives. So this is where like we see the major shift happening across the industry. Like instead of designing the complete FPGA system from the scratch for every product, many organizations started exploring for the proven platforms. So where we see a system on module, also known as a SOM, becoming the very attractive one. So instead of redesigning same infrastructure again and again, the SOMs already integrates the FPGA, memory, clocking, powering, and other supporting circuit in a very compact production-ready module. And at iWave, like the SOM has been our core focus for more than decades. So we are in the industry for more than 25 years. And when it comes to iWave's journey with Altera, like we have we had Cyclone 5 based Q7 SOM. From there, like we continued supporting successive FPGA generation, including ARIA 10, Statix 10, and today like the latest Agilex families. Like we started with Agilex 7 based SOMs, followed by Agilex 5 and Agilex 3, and also like we, as you can see, we have multiple SOM on Agilex 5 and Agilex 3 with the different packages, considering the different market requirement. Also, like we recently launched our Agilex 9 based SOM as well. So if you simply look at this slide, like it may appear as a product timeline, but for us, it represents our continuous engineering investment. As every new like FPGA generation introduce a good amount of challenges, we take complete ownership, and we make sure whenever the FPGA SoC vendors introduce new SoCs, we want our customer to start building their application immediately, like without spending months and solving the complex hardware related challenges and the bring up. Yeah. So so now let's look at our Agilex 9 portfolio. So as we can see like how iWave helps customer to move from idea to the final product in a much faster way, and also with the very lower development risk. So on Agilex 9 platform, like we have our Agilex 9 wideband MCP1 system on module. So it is an industry-grade SOM built in 82 cross 111 for like 111 mm form factor. At the heart of the this module, we have Agilex 9 AGR-W014 based RF SoC. So of like, as you can see, like it is very compact, like a R17B package. At high level, the SoC supports a quad-core ARM Cortex A53 processor with the 1.4 million logic elements and 16 FGT transceivers and 4 ADC and DAC. Both can support up to 64 gigasamples per second. Also, like on SOM, like we integrate 8 GB DDR4 with the ECC for both HPS and FPGA with the like 8-bit ECC, and we have eMMC, QSPI, and EEPROM, so which can be upgraded as per customer requirement. Also, we do have on SOM Ethernet 5, USB OTJ5, and also clock circuit. So we have taken basic all the clock requirement for the smooth function of this RF system, and also we understand the requirement when we have multiple systems on a platform, so it is required to maintain the phase. So we have a provision to take the reference from external carrier board or external system. So with the taking reference from external source, we make sure that complete system are in phase. Also, all the unused signals and transceivers, we have two high-speed board-to-board connector from Samtech, which can support the like 58 gigabit per samples, and we are taking almost all the unused IOs to the board-to-board connector, so which can be used in the development of the carrier board. Similarly, as you can see the golden color connector. So there we are taking all our RF signals. So each like for ADC and DAC, and that connector also supports the required 64 gigasamples per speed. And so if you look at the most of the RF systems, like FPGA platform usually remain the same. So but like RF and like it's on keep on changing like from application to application, and it's like for most of the time like what we do, like we just need to modify the front end. So in our overall concept, like we have separate front end module. So as you can see the image on the right, so our default development kit comes as a PCI card. So we also do have an internal like team. We build our own thermal solution, and as you can see our front end board. So our default like we sit with the front end board with just a balloon with the 1 gigahertz to 50 gigahertz bandwidth. So that it can be customized based on the requirement. Also, like if any customer want to make it with their own uh, front end card, they can easily develop this card, and they can validate their application. In case if they need iWave to develop, so we are also uh, uh, ready to make the front end card as per their requirement. So now if you see our second product, that is Agilex 9 mid-band. So here it is almost like in form factor is almost similar to our uh, wideband. So here MCP3, that is AGR M027. So here like we have the more like 32 FGT transceivers, and we have more 20 and 16 ADC and DAC. Along with that, we have like 2 DDR. Like in the previous year, as you've seen, we had only one DDR for FPGA fabric. So here we introduce one more DDR for FPGA fabric. So most of the other things are similar to MCP1 SOM, and next is like MCP 2 based like wideband SOM. So here it is almost similar, like only major difference is like we will get 8 ADC DAC, which both can support up to 64 gigasamples per second. And with the almost similar feature in align with the other MCP based SOMs. Along with SOM, we do have off-the-shelf COT modules. Like we have a 3VPX plugin module, like which is a SOSA aligned module. We are using like our module is aligned with the module profile of 16.6.13n and slot profile of 14.6.13. So all the ADC lines are taken to Vita 67.3 connectors, and all the FPGA transceivers are taken to the VPX connector. Also, on the other hand, if you can see the PCI card. So as I mentioned, like this is like a standard PCI connector which supports 8-lane Gen 4 PCI with the PCI length of 3/4 of standard PCI form factor length. So this can be like easily we can integrate this into a server system for like post signal processing and application development. So once the system is ready, like it can be like same application can be easily deployed to the final platform, like with minimal changes, because like so we can use the same SOM and reuse across different industry. So all the development done in the development stage can easily taken to the production phase. Yeah. So when it comes to Agilex 9, the roadmap. So as we like, you can see like we already have Agilex, the MCP1 based SOM, the UVPX card and PCI card. We are ready. We already shipping this. Also, when it comes to MCP3, it is almost completed. The samples will be available Q4 of this year. And when it comes to MCP2, so it is almost in the design stage, almost in the final design stage. Samples will be available in Q1 end of 2027. So in align with Altera's MCP4 roadmap, we do have plan to make a SOM using MCP4. So as you can see, once if somebody design a system using MCP2, and later if they want to migrate to, or they can want to upscale the design with the more logic elements or with more higher memory performance. So they just have to replace the SOM instead of completely redesigning, validating the carrier card as complete system. So that is how we are supporting most of our customers. And yeah, so as we see, building high performance RF platform is certainly challenging, but that is just a beginning, because once the hardware is ready, the next step is providing the next step, you have to make sure that hardware is performs exactly how it is designed. It's especially if for RF system, the performance cannot be assumed, it has to be measured, verified and documented. So that's why that Direct RF platform developed at iWave, it goes through a comprehensive RF characterization process. We evaluate the complete RF signal chain, from input and output, and understand the test condition. Also, our engineer team measure key parameters, verify signal qualities, check the performance of converters, evaluate the clocking behavior, and ensure the overall system is operating within the expected market and expected specification. And also we generate a detailed RF characterization report and share with our customer, so which gives a confidence on our hardware, so that they can which allow them to focus immediately on developing their own application, and also spend more quality time on their USPs. Yeah. So similarly, when it comes to development, in many projects, engineers also spend a good amount of time on software integration and FPGA development. And as part of the deliverables, along with the hardware, we enable complete software and FPGA ecosystem to our customer. So every platform comes with a product, is a production ready, Linux BSP. So that includes a bootloader, Linux kernel, device driver, configuration file, and other essential software components required for the bring up and for the system level. So we also provide a detailed user guide, complete Cortex reference design to validate all the hardware features supported in our development platform. So it provides a good starting point for both the software and FPGA development. So customer can immediately begin the modification of our existing validated design and build the system on top of it. So in general, so we provide engineering service also, for example, other than the deliverables, we provide a regular BSP and FPGA updates. We do have our FPGA expertise. We have our internal IP portfolio. If customer want, we can port those IPs. We can integrate the IPs before delivering the boards. Also, if they want, we are capable to develop a custom IPs as required. So now everything we have seen so far is based on the standard platform. So we provide also the custom carrier card design service for our case SOM. Also we understand every custom requirement is not straightforward. Every project has its own performance target, mechanical and environmental constraint. So that's why whenever required, we are flexible enough to take up the complete board development under our ODM engagement program. So we first understand the customer's requirement in detail, Then we propose more suitable architecture, whether it is a SOM plus carrier card approach or like a complete chip down design. So we are like whichever is aligned with customers, like mainly on their technical and commercial requirement. So like we also define, like as part of our ODM approach, we define the detailed acceptance criteria for every major requirement, and then take the complete ownership of product development, including hardware, software like BSP and RTL development. So even system integration, like even like customer required, like we take the thermal solution and the enclosure design. So everything like we deliver as agreed in the acceptance criteria. So once the like design is completed, we build engineering sample units and perform the comprehensive testing and validation, and also support the customer throughout their validation phase. And after successful verification from the customer, if needed, we also support in environmental and regulatory qualification and certification as per the scope of the work. And also our support does not stop there. Based on the customer's need, we also take the ownership of the product lifecycle management. We ensure the platform is always supported with the stable and a secure BSP. That is very essential for in the cyber security. As like we also know that the current in the current uncertainty in the global electronic supply chain. So at iWave, like we take the complete responsibility of sourcing the component, managing the obsolescence, and also we make sure that the production continues as per the customer requirement. Also, when it comes to the product longevity, so most of the product longevity program will be aligned with the SOC vendors longevity program. Yeah. So to summarize, like iWave always there to support customer in adapting the latest Agilex Direct RF technology with the shortest possible development cycle. And as you can see, the same Agilex platform can be leveraged across a wide range of application, including radar, software-defined radio, electronic warfare, SATCOM, with very minimal changes. And at iWave, our business model is very flexible, either supplying just a SOM model or a complete system development. Like we are open for both kind of opportunities. So we would be happy to discuss and know how we can support your team from the concept to the production in your journey. And we invite you all to contact us at mktg@iwave-global.com. And also you can visit our website, iwave-global.com, and know more about our product and solutions. Yeah, with that, I would like to thank you all for your time and attention. Over to you, Sophia.
All right. Thank you, Ahmed and Shriram, for wonderful presentations. With that, we'll get started with the live Q&A session. So thank you, everybody, for participating in the chat box. Let's get started here. All right. First question, let's see. How are we ensuring long platform lifecycle support for Agilex 9?
Hey, Sophia, I think this is likely for me, so let me take that. So Agilex 9, that's a good question. Agilex Die has a product lifecycle support until 2045 with the Agilex 9 FPGA die being manufactured in the US. Along with that, we have long-term supply agreements in place with all our suppliers. So the customers can have peace of mind, knowing that the systems they design with Agilex 9 will have supply continuity for decades.
Great. Thank you, Shriram. All right. Next question. Ahmed, this one's for you. If we already have an FPGA design team, what additional value does iWave bring as an Altera authorized partner?
Yeah, that's a great question. Yeah. So having in-house FPGA team, yeah, definitely is a strength. But our goal is not replace that team. It's like instead help them to get the product um, in a better and faster way. As a Altera's authorized partner, we have a special access to latest FPGA technologies, design resources, and technology support, technical support. So that allow us to develop and validate the production earlier is in a very quicker manner. So your engineer team can start working on the application immediately, as I mentioned in the slide, like during the presentation. Also, like one more, like this scalability. So since we maintain the pin compatibility across our SOM, so in case if there is a scalability, like if you want to upgrade the performance of a system, it is much easier to migrate to next device with very minimal design change. Also, one more point, as I highlighted, so after sales support ecosystems, we continue to maintain an optimized and stable and secure BSP for all our uh, product portfolio, and also we provide the long-term product life cycle management. So that includes mainly the component obsolescence management. So overall, allowing we take the that part of the burden and allowing your engineer team to stay focused on your innovation and your USPs. And so yeah, in general, a customer can use their engineering expertise and rely on iWave as their technical trusted partners.
Great. Thank you, Ahmed. All right, next question. Can you elaborate on how swap is 10x improvement, specifically power, when compared against these other devices, Xilinx and or off the shelf?
Okay, I think that's for me. So the improvement in swap is compared to the discrete solutions that use that have a separate chip for the AD's theta converter and for the FPGA. Now the 10x number is what we have heard from customers. It ranges anywhere between 4x to 10x in terms of size, or it could be in terms of weight and power. But we do have uh, an app note that has the numbers on comparing both latency as well as power with a discrete solution that uses Agilex 7 with a JSD 204B and C implementation, and comparing that to the latency and power numbers that you get with the Agilex 9 MCP2 AGRW 027 device. I can send out that that particular app note in the chat here. So anyone who is interested can take a look at it. It's actually a blog, and the blog at the end has a link for the app note that you can click on and you can read up more on it. So let me send that out in the chat. Thank you for that question, though.
Great. Thank you, Shriram. All right, next question. Ahmed, is it possible to control the ADC and DAC settings from the processor / Linux?
Yeah. The question is whether we can tune or set the ADC and DAC parameter from ARM core. Yes, we can. We have validated by integrating the Linux driver, and also we have supported the same. We can support the same. We use the 8-tile Linux driver, and we are able to access the and update RF tile register. So yeah, that is possible. We already done in our dev kit.
Great. All right, moving down. Let's see what we have. Are Altera's Agilex 9 development kits available through DigiKey and Mouser? If so, which development kits are available?
Okay, that's, I think, for me. So Agilex 9 development kits from Altera are not stocked by distributors like DigiKey and Mouser. Altera sells these boards directly, and you can visit altera.com to check out the various dev kit offerings for your needs. Actually, let me just send a link to where you can find these dev kits. I'll send the webpage link. But one thing I wanted to point out was that if you're considering purchasing a dev kit, and if you click on order now, you will be asked to fill out some contact information, and an Altera sales rep will contact you back to understand your requirements further, because this is a product that cannot be sold to certain countries. So we want to make sure that our sales rep understands your requirements before going ahead in the ordering process. So let me send out the link where Agilex 9 development kits can be found. Thanks for that question.
Thank you, Shriram. Right, let's see here. This seems like a board question. Can multiple boards be synchronized together? I believe this is for iWave.
Yes, as explained earlier, like in our SOM, we have taken care of the complete clock supporting circuit, which are like required, all the required, which are required for the RF systems. Also, like the SOM supports external reference clock input for multi-board synchronization. So, since the complete clocking architecture is integrated on SOM, so only providing a common reference clock like 10 megahertz from the baseboard or from external sources can be used to make sure that all the boards are in synchronized. Yeah, yeah. The answer is yes, it's possible. And thank you for the question.
Great, thank you. Let's see. All right. This is for Shriram, Altera. So you mentioned Agilex 9 devices are suitable for quantum computing. Can you provide more details on that topic?
Yeah, sure, Sophia. So that's a good question, because quantum computing is an emerging area where Agilex 9 has unique advantages. So it's quantum computing is something that we recently, as Altera, announced as a technology segment where we offer FPGA-based solutions, providing benefits to quantum OEMs that as they ramp into more commercial availability of their systems. Now, depending on the modality of their quantum computing architecture, Altera's FPGAs can be used in a couple of different areas. It can be used for qubit readout hardware, it can be used within the qubit control hardware, and also for within quantum error correction processing. And because RF interfaces are primarily used to interface with the qubits, the ADC and DAC performance of the Agilex 9 devices have advantages over other solutions, especially for the qubit control and readout hardware. Like the wideband devices obviously have higher IBWs that they provide, and the Agilex 9 medium band device have a higher bit resolution and more channels that can be used for qubit manipulation operations.
Thank you, Shriram. Moving down the line, another question for you, Shriram. Other than larger FPGA density, how is Agilex 9 medium band device a better solution than the RF SoC solutions today?
Okay, so I think one obvious benefit is that you wouldn't need companion FPGAs that you typically have with the RF SoCs, because the medium band has more FPGA resources, but also the medium band device has a non-interleaved RF architecture. I highlighted that, as opposed to the RF SoC, which has an interleaved architecture. So you do not have to deal with non-linearities and calibration concerns at the system level. Along with that, the medium band device also has a higher ADC channel count, up to 20, if you take the feedback channels into consideration. And it offers twice the system bandwidth processing capability. So what that means is number of channels into the IBW that you can get on each channel. So that's twice the system bandwidth processing capability as compared to the competition. So yeah, those are the primary benefits, and obviously the fabric benefit as well, right? In terms of better performance per watt, as well as a better design efficiency. What that means is, even if you have higher resource utilization in your FPGAs, your Fmax will not drop as steeply as with competing devices.
Thank you, Shriram. All right, last question. We have time for Ahmed. What are the power consumptions for the SOM?
Yeah. So like the power consumption like is mainly depend on the FPGA resources utilized. The power consumption observed like when we use our SOM in our direct band platform with up to 30 to 35% of resource utilization. So we observed like it is coming somewhere around 50 to 55 watt. So it's basically and directly it depends on how much we utilize. Yeah.
Great. Thank you, Ahmed and Shriram. That's all for today, everybody. Thank you so much for joining us and being present and asking questions in the chat. We really appreciate it. On behalf of Altera and iWave, we hope that today's session provided valuable insights into how Altera's Agilex 9 Direct RF-Series FPGAs, together with iWave's production-ready platforms, can help accelerate the development of next-generation SDR, radar, and EW systems. Thank you so much, and I hope you have a great rest of your day.